In step 7 of exercise number 7, the remaining parameters for iMachining 2D are explained in detail, and the advanced features and controls are used to demonstrate their effects on the iMachining toolpath. These include any advanced features and controls that exist on the link, motion control, and miscellaneous parameters pages. For the purpose of this exercise, you will see panning and zooming to different areas of the part geometry. In the SolidCAM Manager, click the Visibility checkbox next to iRough Outside Shape and double-click the operation. The iMachining operation dialog box is displayed. Switch to the link page. In the in-pocket positioning area, there is a parameter called Z-clearance. This defines the height the tool is picked up off the floor when repositioning from one cut to the next. By default, 0.08 mm is used for Z-clearance. For this operation, enter a value of 0.24 mm. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. As you can see, the toolpath is updated on the model and a 0.24 mm Z clearance is used for the operation. The Detour length slider enables you to adjust the distance the tool is allowed to travel around the stock when repositioning from one cut to the next. iMachining automatically calculates this value to keep the tool down as much as possible, reducing retracts and long position moves. If the detour length required to reach the next pass exceeds this value, the tool will retract to the clearance level and reposition via a straight line movement. For example, reduce the detour length slider to 14 mm. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. As you can see, the toolpath is updated on the model, and the tool is not allowed to reposition via a detour that exceeds 14 mm in length. The Max Arc Size slider enables you to adjust the maximum size of the 3D arc that is used when repositioning from one cut to the next. iMachining automatically calculates this value based on the current tool diameter. For this operation, slightly increase the max arc size by moving the slider to the right. Click Save and Calculate to save the data changes to the operation and calculate the iMachining toolpath. As you can see, the toolpath is updated on the model and the max arc size for helical reposition moves is increased. Next, switch to the Motion Control page of the iMachining Operation dialog box. This page enables you to optimize the calculated toolpath according to the kinematics and special characteristics of your machine. Using the point interpolation options, SolidCAM enables you to perform interpolation for the linear tool movements. The Approximate Arcs by Lines checkbox enables you to control the process of arcs approximation for the current operation. For more information regarding these parameters, refer to the SolidCAM milling help. Next, switch to the Miscellaneous Parameters page of the iMachining Operation dialog box. With the Retract After Every Cut option, you can quickly disable detouring of the tool when repositioning from one cut to the next. Now, the Fit Arcs checkbox is enabled by default. This option will fit arcs in the iMachining G-code. The Cutting Angle Tolerance parameter is used to group sections of iMachining toolpath that will fall within the specified tolerance, and then arcs are applied to those sections. A small tolerance can greatly reduce the amount of G-code and is especially beneficial for machines with limited memory. In the in-process simulation area, there is the option to show toolpath during calculation. This is a useful tool for verifying the iMachining toolpath during calculation. Let's now move on to constant chip thickness control for arcs. I should first note that the feed rate is automatically corrected when iMachining cuts in corners. By doing so, we are able to maintain a constant chip thickness. This helps to keep the tool load constant, which increases tool life. It's also less likely that dangerous cutting conditions could develop. However, you may find a small increase in your cycle times because of this. Now, if you decide that faster cycle times is more desirable than maintaining a constant chip thickness, then you should consider using this slider. Basically, the constant chip thickness control for arc slider enables you to control the feed correction for arcs. The position of the slider is set to 100% by default. If kept at 100%, iMachining is informed to maintain a constant chip thickness when cutting in corners. Moving the slider to 0% informs iMachining to maintain a consistent feed rate between cutting in a straight line and cutting in a corner. Now, the result may be faster cycle times, but beware, with increased chip thickness in corners, of course, comes increased tool load. Using the Exit button, close the iMachining Operation dialog box. In the SolidCAM Manager, resynchronize the subsequent iFinish operation. Right-click iFinish Outside Shape and select Calculate. At this stage, Step 7 is complete and the exercise has come to an end. The remaining parameters for iMachining 2D were explained in detail, and the advanced features and controls were used to demonstrate their effects on the iMachining toolpath. This concludes the iMachining 2D exercises for the interactive one-day training course for iMachining.